Thank you for logging in. Today's podcast I'm looking at the remainder theorem. I've actually got an exam question for us to look at here. I'm told that this is a function and I'm asked to find the constants p and q. The information we're given is when divided by 2x minus 1 there is no remainder. So basically f of a half, which will be 6 over 8, p over 4, q over 2 plus 8, and this is the most important thing, is equal to 0. If I multiply by 8, I'm left with 6 plus 2p plus 4q plus 64. If I take the 64 and the 6 over, which becomes 70, and over to the other side, I'm left with 2p plus 4q equals negative 70. That's the first equation. The second is that when divided by x minus 1, the remainder is 7. So here, f of 1 will give me 6 plus p plus q plus 8, and remember, it is minus 7. Tidying up, 6 and the 8 is 14, take it over, becomes negative 14, this becomes p plus q equals negative 21. And it is these two equations that I'll be using. If I multiply this equation by 2, I get 2p plus 2q equals negative 42. I use the first equation, which is 2p plus 4q equals negative 70. And if I take one away from the other, I'm left with 2q equals negative 28, q equals negative 14. That's my first solution. If I now use this equation here, p plus q equals negative 21. I've already have q, so p is negative 21, take away q, which is negative 21, take away negative 14, which leaves me p equals negative 7. Now the second part of the equation asks us to factorise completely, and if we set the equation up here, I've got the value of p and q here, and 6x squared divided by 2x is 3x squared, so that's 3x squared, and if I multiply that 3x squared by that, I'm left with 6x cubed, and that gives me negative 3x squared. Tidying this up, negative 4x squared, bring everything else down. Negative 4x squared divided by 2x gives me negative 2x. Multiplying negative 2x by that gives me negative 4x squared plus 2x. Be careful, the signs have changed. And taking away, I'm left with negative 16x plus 8. And 16x negative divided by 2 gives me negative 8. And then the last bit is negative 16x plus 8 gives me 0. The question asked, factorise completely this function. We've already been told that 2x minus 1 is a factor, so what I'm looking for now is to factorise this quadratic. So we'll put a 3x there and x there. I need factors of 8. Factors that sort of come to mind is 4 and 2. So we'll put a 4 there and a 2 there. We need negative 2x, and if you look at this, 3x and 2 gives me 6, that gives me 4. So that has to be negative and that has to be positive. What you'll notice is that the remainder theorem is very similar to the factor theorem. The only difference being that with the factor theorem there's no remainder, and with the remainder, when you divide, you're actually told that there's going to be a remainder, and we can use simultaneous manipulation, or we can also compare coefficients.